Hey, this is Mr. Ward. I'm going to do a key for the exit ticket for today, 18.1, week 18, day 1. So let's start off with, after you've answered other questions, let's prove it. And I give you a hint that Kappa will be your friend. Corresponding parts of congruent triangles will be your friend. So we have some information that we can start organizing in a second, but we're trying to prove that AC bisects this segment BD. Now, in order to do that, we really are going to need to prove that BE and DE are congruent. So it would be helpful to be able to prove that ABE or A and ADE are congruent, or BCE and DCE are congruent. Either one of those would get us where we need to be. So let's start off seeing what information we have. Can we prove either of those by themselves? Well, we know A is equidistant. A is equidistant from B and D. That's another way of saying that this segment and this segment have the same length. So let's mark them up. So that segment and that segment are congruent. We also know that AC bisects BAD. So here's BAD, and AC is bisecting it. That means that this angle will be the same as this angle. So let's label that as well. So this angle is congruent to this angle. Those are congruent angles, flump and flump. And that's based on this bisecting. Okay, so that's information we have. So let's start thinking about what we can say. So after the givens, we can say that angle BAC is congruent to angle BAC. Okay, so now, well, do we have enough information right now to prove? We actually could prove ABE and ADE are congruent right now, because we can say AE is congruent to itself. Okay, AE, is congruent to AE by reflexive. Okay, and so, and by the way, this one I should have stated, those are congruent by definition of angle bisection. Okay, so now let's label that reflexive side that is we now know is congruent to itself. So I'll use magenta there. Now, once I've done that, I now have a side angle side, and that way I can prove now that triangle BAE, okay, now I can say triangle BAE is congruent to triangle DAE by side angle side postulate. Now, then I can prove that BE and DE are congruent. BE is congruent to DE by Kappa. And then I can say AC bisects BD by definition of a bisector. Okay, and that is what you need. Well, let's go on to the next one here. It says prove it, and you'll have you have to prove a couple of triangles that do not contain BD. Have to prove a couple triangles that do not contain BD are congruent first, and then use Kappa. Also consider that what the measure of two angles would be if they're both supplementary and congruent to each other. So let's look at what we need to prove. We need to prove that AC is the perpendicular, that means perpendicular, bisector of BD. That means that it cuts BD in half and makes right angles here. Okay, so we had to prove two things. We had to prove that BE and DE are congruent, and then we're going to need to prove somehow that these angles are right angles. And if we can prove that these two angles that are clearly supplementary to each other are also congruent, then they had to be 90 degrees, because two angles that add up to 180 degrees and are the same are half of 180 degrees. Okay, so let's see what we have. We have AB right there is congruent to AD. We have that information. We have BC is congruent to DC. All right, and as you can see, we don't have enough information to prove these two pieces are congruent or anything about these angles yet, but we do have enough information to prove that these side triangles, ABC and ADC, are congruent. Okay, so let's start with the proof. So we've got the givens. Okay, after the givens, then we can say AC is congruent to AC by reflexive. And let's do that. So I'm just going to use a light blue there. Okay, and now we can prove that triangle ABC is congruent to triangle ADC by side, 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 because we have three sides that are congruent. Now, once we've done that, we could either prove that these two little triangles are congruent or these two little triangles are congruent. Doesn't really matter which, because what we now know is that this angle and this angle are congruent. Okay, and so we can, I'm going to just say, go either way. I could do ABE and DAE, or sorry, BAE and DAE, or BCE and DCE. I'll go over here on this side. Okay, BCE, triangle B, or angle BCE is congruent to angle DCE by Kappa Kappa. Okay, now I'll label that. Okay, so let's label that flump and flump. And now I can say that EC is congruent to itself. Reflexive, I'll label that. Okay, so I'm just going to add a little labeling there. And now I have enough information to prove that BCE, triangles BCE and DCE are congruent. Triangle BCE is congruent to triangle DCE by side, angle, side. Because I have a side and an angle and a side with that reflexive piece. And once I have that, I could prove that angle BEC and DEC are congruent. Angle DEC by Kappa Kappa. And if they are congruent, we can just do a little bit of math. Okay, so now we can say that angle BEC and angle DEC are right because they are both supplementary and congruent. So they must both be 90 degrees. Okay, and then we can also say that BE and DE are congruent. We don't have enough yet. BE, because we need not just prove that it's perpendicular, but it's a perpendicular bisector. BE and DE is congruent to DE by kappa kata ka. And then we can say that AC is the perpendicular bisector of BD by definition of a perpendicular bisector, which is that it divides a segment in two equal parts or congruent parts and does so at a right angle. All right, I hope that helped.